Recording. All right, here we go. Hey, everybody. Our next topic is to represent a linear function in table form. So let's take a look at what we have on the whiteboard here. What we have is, given this table, we want to find the linear function f of x. Well, a linear function is defined by y equals mx plus b. And in this table, we have x values 0, 1, 2, 3, 4, and we have f of x, which is also called y. So we have x values, we have y values. These terms can be used interchangeably. F of x means y means f of x. So my y values are 7, 8, 9, 10, 11. Going back to linear function, well, linear means line. Equation of a line is y equals mx plus b, where m is our slope, and we've been defining that as rise over run. Here we're going to define it, well, a little bit differently because we have numbers. Doesn't make it wrong, it's just we're using another definition. And the b means our y-intercept, which basically means where does a function cross the y-axis? Because remember, we have an x-axis and we have a y-axis. So this number that we're going to solve for, b, represents the y-axis, which means where does my graph cross the y-axis? Now, in general, when you have an xy coordinate plane, it's your x-axis, and you have your y-axis. And you have many points on this plane that are defined by coordinate pairs, meaning if I start with my origin, I know that one point is defined as this one point is defined by the coordinate pair of x equal to 0, y equal to 0. I can pick another point and suppose the coordinates at that point is 1, 2. But there's a way to write this x and y coordinate pair, and we can do it this way. If this is our first point, I can write this as x1, comma, y1. Since this is my first point, 0, 0, in general, I can write that as x1, y1. If you'll remember that all pairs of numbers are normally written as x comma y, right? But if we have more than one pair, well, we want to identify, okay, this is my first point. Well, I'm going to assign 1 the value to x and 1 the value for y. So then for my second point, I'm going to call my x value, which is number 1, I'm going to call that x2. X2, and then my y value, I'm going to call that y2. So it's different ways to represent this 1 point. In terms of numbers, it's 1, comma, 2. In terms of x, comma, y notation, since it's my second point, I can say x2, comma, y2. If I had a third point, I can write it in general as x3, comma, y3. Okay, so why are we doing this? Because we're going to add another definition for slope. We have said in the past videos that slope is equal to rise over run, and that is true. Another definition is the slope, which is m, is equal to what they call the change in y over change in x. Okay, so slope is equal to change in y over change in x. Well, if I want to first talk about 2 points, because I need 2 points to define my slope, let's take a look at the points that are inside this box. And we're going to substitute those values into this word formula to make this thing make more sense. So now my slope m equals my change in y. Well, that means I'm going to take the difference, y2 minus y1, over my change in x, which is x2 minus x1. And this is a formula that we're going to use to find the m in this equation up here for y equals mx plus b. So now coming back to this graph here, or to this table, okay, if my x value, this first value is 0, my y value is 7. So now I can label these like this. This pair of x is equal to 0, y equals to 7, I can call that 0, x1. And the y value is going to be y1. My second pair, where x equals 1, y equals to 8, I can call that x, the one value is going to be x2. And my 8 is going to be the value y2. And I can continue identifying it this way. My x2, this 2 would be x3. This will be y3. This will be x4 equals 3, y4 equals 10, and so on. But now to calculate my slope, because I need my slope, and then we'll calculate what b is. But first, to find my slope, I'm going to use m equals to y2 minus y1. And I've identified x1, y1, x2, y2. Now we're going to substitute these values into this equation to calculate our slope. And this slope m is going to go into our equation for a line y equals to mx plus b. So again here, m equals to y2. Well, y2 in this case is 8 minus y1, that's 7. For my numerator. Now for my denominator, I need x2. Well, my x2 is equal to 1. Then minus x1. x1 here is equal to 0. So now this gives me, for my numerator, 8 minus 7 equals 1. 1 minus 0 equals 1. And now 1 divided by 1 equals 1. And so now for y equals mx plus b, now that I know what m equals, which is 1, I can substitute 1 in for m. But we usually just write not just 1 x, but 1 times x is just x. So now we're down to the equation y equals x plus b. Now we need to find what value b equals. And so what we can do, we can pick any coordinate pair, x1, y1, and we can substitute those in to solve for b. So that's exactly what we're going to do. Let me erase some of the things over here to have more space. So now to find b, which is our y-intercept, I can choose any x1, xy pair and substitute that in. Okay. Okay, so what I just said, just written out in words. To find b, we're going to choose any xy pair, xy, xy, and we're going to substitute the x value into here, the y value into here, and then we're going to solve for b. So I'm going to choose my first pair, 0, 7. You don't have to choose that. You could choose any pair, 0, 7. You could choose 1, 8, 2, 9. But I see I've got a 0 there, so I'm going to choose that because makes solving for B a little bit easier. So I'm writing I choose. So I choose the pair 0, 7. For my X and Y, and now substitute. So for this equation Y, here my Y equals 7. So I'm going to write down here 7. Bring down my equals, and now X, well, my X value is 0, and bring down my plus B. Well, that's still 7 equals, well, 0 plus B is just B. So this brings it on home. This finishes it up. Now that I know my slope, M equals 1. I know my y-intercept, B equals 7. Now I can substitute these two values back into my general equation, and I'll have the equation for the line that represents these data points. So again, just in general, y equals mx plus b. So y equals m equals to 1 times x plus, and b equals 7. And then this y is f of x. Now, do you have to write both f of x and y? No. You can choose one or the other. You can write y equals to x plus 7, or you can write f of x. You can write just f of x equals to x plus 7. And that ends that problem. And this is our last problem for representing a line. We're calculating a line function given table values. So for this next one, I have to draw a couple of tables like this, and we have to pick which table contains all x values and all y values that satisfy a function. Well, that sounds bad. Let's go ahead and start writing. Give me a second, and then we can explain this a little bit better. Okay, so here's our first table. X value of 0. Y value of -3. X value of 1, Y value of 13. When X equals 2, Y equals 26. For my second table, -0, -3. 1, 11. And then 2, 25. So that means when X equals 2, Y equals 25. All right, in my third table, -0, -3, 1, 11, and 2 and 22. So a good question to ask is, what in the world do you do with all these? Well, we have to substitute. Oh, I'm missing something. Missing something. Oh, the actual function. F of X equals -3 plus 14x. So what they want us to do is determine which table is it, table 1, table 2, or table 3, whose X values, when substituted into here one at a time, would give me these Y values. So I'm going to start with just table 1, and I'm going to substitute 0 in for X, and let's see if we get -3 as the answer. So I have when X equals 0, I'm substituting in 0 for X, so I'm writing F of 0. So F of X is F of 0 when X equals 0. So that equals -3 plus 14 times X. But X is 0. So that gives me just -3 plus 0. Okay, so for table one, I'm good so far. I have to check each pair. So when I substituted x equals 0 into that equation, I did get y equals to -3. So that means this point satisfies this equation. It makes it true. So now let's check when x equals 1. So now I'm going to substitute 1 in for x and see if we get 13. When x equals 1, I have f of 1. Oh, let me stop right here for a second. Notice what I just circled here. When x equals 0, y equals -3. Well, that's the same value I have in all three tables. X equals 0, y equals -3. Table 2, when x equals 0, y equals -3. X equals, in table 3, x equals 0, y equals -3. Well, since all these values satisfy this equation, that's the reason why I'm moving to my next set of x and y values. So now back to table 1, when x equals 1, we want to see if y equals 13. If it does, that's good. If it doesn't, that means we can eliminate this table as containing data, xy data, that satisfies this equation. So f of 1 means we're going to have -3. F of 1 equals -3 plus 14 times 1. Again, we just substituted 1 into this equation up here. So I substituted 1 for x. And now I have to simplify this to see if I get 13. Bring down my -3. Now plus 14 times 1 is 14. And now -3 plus 14 is 11. Okay, I got 11, but I was expecting 13. Well, so since that did not happen, I can eliminate table 1 as containing x, y values that satisfies that equation. So I can just put a big X. Now notice for tables 2 and table 3, for my second points, when x equals 1, y equals 11. When x equals 1, y equals 11. Well, I have that in tables 2 and 3. So now I need to check to see when I substitute 2 in for x, do I get 25 or do I get 22? So now when x equals 2, f of 2 equals -3 plus 14 times 2. I'm circling both because both values are 2. We're looking to see, is my y value going to be 25 or 22? We'll bring down my -3. And now 14 times 2 is 28. And -3 plus 28 is 25. So that means the data in this table satisfies this equation. When I put in 0, I do get -3. When I put in x equals 0, I get -3. When I put in x equals 1, I get 11. When I substitute x equals 2, I do get 25. So that means this data here does not satisfy this, because here for my x value, I have 2, but for my y value, I have 22. But that's not correct. So table 2 contains the data that I can use to actually graph that function, f of x equals -3 plus 14x. So the question here was to identify which table contains data that could be used to graph that equation, which is actually the equation of a line. Well, the table is table 2. And you may see more examples like this that may have maybe not just 3 tables of data, it may have 4 or 5, but you want to go through and by substituting your x values in to see if you get the corresponding y values. Well, if you don't, then you can eliminate the table. You can eliminate the table, and you'll be left with one table that contains data that can be used to graph this equation for a line. So that's it, everybody. Take your time, work through it, and if you need to, rewind the video back a little bit, pause it, take notes, and just keep practicing. And I will see you all in the next video. Take care.